Galileo Galilei was an Italian physicist, mathematician, astronomer, and philosopher who made significant contributions to the development of modern science. Born on February 15, 1564 in Pisa, Italy, Galileo is considered one of the most influential figures in the scientific revolution. His work revolutionized our understanding of the natural world and laid the foundation for future advancement in physics and astronomy. Galileo was born into a family of musicians. Initially, he enrolled at the University of Pisa in 1581 with the intention of studying medicine. However, his interest shifted toward mathematics and natural philosophy. Despite not completing his medical degree, Galileo's passion for mathematics led him to study the works of famous philosophers and scientists of the time, and he eventually became a professor of mathematics at University of Padua. Galileo was very close with a beautiful woman from Venice named Marina Gamba. Together, they had two daughters and a son. They were never formally married. It's a bit of an interesting and complex aspect of Galileo's life, especially when considering the social norms of his time. In the 16th and 17th century, it was indeed common for many scholars, especially those in the science, to remain unmarried or to delay marriage. This was often due to the demanding nature of academic and scientific work, as well as the societal expectation that a scholar's personal life should remain somewhat detached from a family's concerns. However, it was also worth noting that Galileo's relationship with Marina seems to have been affectionate, though he never married her.
Galileo Galilei made a revolutionary contribution to science, particularly in the fields of astronomy and physics. By improving the telescope and using it for astronomical observations, Galileo discovered that Jupiter had moons orbiting around it, which challenged the geocentric model of the universe that placed Earth at the center. He also observed the phases of Venus and the rings of Saturn, providing further evidence for the heliocentric theory, which proposed that the Earth and other planets orbit the Sun. Galileo's work on motion, including his studies of falling bodies and the principle of inertia, laid the groundwork for modern physics. His insistence on using observation and experimentation to understand natural phenomena helped establish the scientific method, shaping the future scientific inquiry and marking him as a key figure in the scientific revolution.
What did Galileo Galilei invent? Galileo is also known for the numerous scientific inventions he made during his lifetime. One of them is his famous telescope. Imagine being able to visualize billions of light years away from us. It is just hard to believe to think about it. However, an amazing invention was made that was able to do just that. In June 1609, Galileo was in Venice when he learned about this Dutch perspective glass that showed distant objects as if they were close up. On the night of his return from Venice to Padua, he figured out how to make his own version of telescope. By teaching himself the arts of lens grinding, Galileo improved the instrument from 3 times the human vision to 8 times, which he presented to the Venetian dome makers. He was the first one to use the term telescope, which comes from the Greek word tele, meaning far, and scopin, meaning to look. The magnifications of objects happens due to the ratio of different curvature on the two lenses. The final telescope is ranging 20 meters in length and 37 millimeters in diameter.
Galileo Galilei made groundbreaking discoveries in astronomy, and he was the first person to observe the moon through a telescope. Unlike the smooth, perfect surface people once imagined, Galileo saw that the moon had a rough and mountainous surface with craters and valleys. This was a revolutionary discovery because it showed that celestial bodies were not perfect spheres as previously thought. In 1610, Galileo pointed his telescope at Jupiter and made another incredible discovery. He saw 4 moons orbiting Jupiter, now known as Io, Callisto, Europa, and Ganymede. These moons, called the Galilean satellites after him, were the first object found to be orbiting another planet. This was a key observation supporting the heliocentric model, which suggested that not everything revolved around the Earth.
In 1610, Galileo Galilei made a groundbreaking discovery that would challenge centuries of astronomical belief. Using his newly improved telescope, he observed four small celestial objects near Jupiter, which appeared to move in a way that suggested they were orbiting the planet. These objects, which Galileo carefully sketched over several nights, would later be identified as the four largest moons of Jupiter: Io, Europa, Ganymede, and Callisto. At the time, the prevailing view was that all celestial bodies orbited the Earth, in line with the geocentric model of the universe. However, Galileo's observations, which he documented in his work Sidereus Nuncius, the Sidereal Messenger, offered clear evidence that at least some bodies, like the moons of Jupiter, orbited another planet. This discovery not only provided crucial evidence against the geocentric model, but also supported the heliocentric theory of Copernicus, suggesting that the Earth was not the center of the universe. Galileo's sketches were pivotal in reshaping our understanding of the cosmos, revealing a dynamic, heliocentric system in which the Earth was not the sole focus of celestial motion.
Galileo also studied other planets and phenomena. He observed Saturn, though he wasn't able to clearly identify its ring due to its limitation of his telescope. He studied the phases of Venus, which supported the idea that Venus orbited the Sun. Additionally, he observed sunspots on the Sun's surface, challenging the belief that the heavens were perfect and unchanging.
Now, let's proceed to the phases of Venus. Using the telescope, Galileo witnessed Venus exhibiting phases similar to the moon's crescent, gibbous, and full. This defined the prediction of the Earth-centered model, where Venus would always appear nearly full. In the heliocentric model, however, this phase was perfectly explained by Venus orbiting at the Sun at those different angles relative to Earth.
Sunspots are temporary, dark region on the Sun's surface, appearing cooler than the surrounding area due to being about 1,500 to 2,000 degrees Celsius lower than the Sun's normal temperature of around 5,500 degrees Celsius. These spots result from intense magnetic activity that disrupt heat convection from the Sun's interior, with the magnetic field in sunspot region up to 2,500 times stronger than Earth's. Typically occurring in pairs with opposite magnetic polarities, sunspots consist of a dark central umbra and a lighter penumbra and can reach temperature of around 3,500 degrees Celsius. 6,300 Fahrenheit. The study of sunspots significantly advanced in the early 17th century, particularly through the work of Galileo Galilei, who in 1610 observed and documented their movement, challenging that belief in celestial perfection. His findings supported the heliocentric model proposed by Copernicus and laid the groundwork for future solar research, emphasizing the Sun, like Earth, is subject to change.
Galileo's observation strengthened his belief in Copernicus' theory that Earth and all other planets revolved around the Sun. Most people in Galileo's time believed that the Earth was the center of the universe and that the Sun and planets revolved around it. His abrasive and outspoken criticism of Aristotelian philosophy and his obvious acceptance of the Copernican worldview, particularly in his dialogue concerning the two-chip world system, led him into serious trouble with the Roman Catholic Church, which placed him under house arrest for the last 8 years of his life. The Catholic Church, which was very powerful and influential in Galileo's day, strongly supported the theory of geocentric or Earth-centered universe. After Galileo began publishing papers about his astronomy discovers and his belief in heliocentric or sun-centered universe, he was called to Rome to answer charges brought against him by the Inquisition, which is the legal body of the Church Catholic. Early in 1616, Galileo was accused of being a heretic, a person who opposed church teachings. Heresy was a crime for which people were sometimes sentenced to death. Galileo was cleared of charges of heresy but was told that he should no longer publicly state his belief that Earth moved around the Sun. Galileo continued his study of astronomy and became more and more convinced that all planets revolve around the Sun. In 1632, he published a book that stated, among other things, that the heliocentric theory of Copernicus was correct. Galileo was once again called before the Inquisition and this time was found guilty of heresy. Galileo was sentenced to life imprisonment in 1633. Because of his age and poor health, he was allowed to serve his imprisonment under house arrest. Galileo died on January 8, 1642. Galileo died January 8, 1642. Galileo, buried between Michelangelo and Machiavelli, is said to have had his gravestone inscribed with the words, "But the earth does move." It's not true.
In a historic declaration on October 31, 1992, Pope John Paul II officially recognized the wrongfulness of the persecution of Galileo Galilei, a pivotal moment in the relationship between the Catholic Church and the science that occurred over 350 years after Galileo was condemned for advocating the heliocentric model of the solar system. The Vatican attributed the blame primarily to the clerics and theological advisor involved in his trial, rather than to Pope Urban VIII, who presided over the proceeding and thought the charge of heresy against Galileo was not formally overturned. The Pope emphasized that Galileo was right, affirming the validity of his scientific assertion. This rehabilitation was informed by the findings of a committee established by the Pope in 1979, which re-evaluated Galileo's contribution and sought to address the tragic legacy of the affair. The acknowledgement aimed not only to rectify a historic wrong but also to foster a reconciliation between science and faith, encouraging dialogues and understanding between these realms, reflecting a broader commitment to learning from past mistakes and embracing the contribution of science in understanding the world.